We are the team number 7, and we are Gerardo Cano, Rodrigo, Luis Arturo, and me, Ixel. Our problem talks about the orbit of the Apollo 11 around the moon, and the problem says that the distance from the moon to the perilum is equal to 68 miles, and the distance between the moon and the Apollo is 195 miles, and the radio is equal to 1075. And also the problem says that the center of the moon is equal a one focus of the graph.
Apollo 11 was the first space flight that landed on the moon. Neil Armstrong and Buzz Aldrin landed on July 20 in 1969.
This mission brought one of the greatest, phrases for mankind, which is one small step for man, one giant leap for mankind, said by Neil Armstrong the moment that he set foot on the moon. This happened around 2:56 International Hour and was accompanied by the collection of 75.6 kilograms of lunar surface so it can be studied on the Earth. By this way, it was a very important act in human history, and as we can see, even those important acts in history can be made and can be exercised in a math class.
July 20th, 1969. Two brave men accomplished something that made the world freeze until glory. The first human stepped on the face of the moon. Neil Armstrong, Buzz Aldrin, two brave soldiers that changed the world forever.
Making his way around the limb, photographing it from various angles, looking at its condition on all sides.
Right in this area there are two craters. The one that's right in front of me now as I look off in about the 11 o'clock position from spacecraft, about 30 to 35 feet across. Roger up.
In the foreground, Buzz Aldrin is collecting a core tube sample.
I hope you're watching how hard I have to hit this into the ground to the tune of about 5 inches, Houston. Roger. It almost looks wet.
Buzz, this is Houston. You've got about 10 minutes left now prior to commencing your EVA termination activities. Over.
Roger, I understand.
So, knowing that the moon radius is 1075, we can calculate it with summing up with the Perilune and Apollone, and the other part of the radius to have the total of 2a, which is 2413. Knowing this value, we can now calculate c. In what way? C, when we sum up the Perilune and the radius, when summed up and subtracted from a, that is 1206.5, we get the value of the fourth side, which is 63.5. And in this way, we can already calculate the points of C and the vortex. And now to calculate for B, we just use the formula B squared is equal to A squared minus C squared, and get as a result 1204.82 miles.
So, once we know the points A, B, and C, we can graph by plotting the points. So, here's the center at the origin, and the distance C, 63.5. That's will be a focus, and the other in the opposite, minus 63.5. Then we know that the distance from here to here, that it means A, will be at 1,206.5. That will be one of the vertex, and there he will be at the opposite sign, minus 1,206.5. And then B, which is almost the same as A, but less, will be at 1,204.82. That means that will give us almost a circle, but not a circle. It's an ellipse. And to graph more precisely, we use the lateral recta with the form of 2b squared over a, and we get that is 2,406.284. And well, here's lateral recta from the co-vertex to the lateral recta, all the way to the vertex, to the lateral recta, and that will be. So now we know the centers of the arcing, we need to put here subtractions for additions. We just put here x squared over a squared. That means 1,455,642. And you add to y squared over b squared. That means 1,451,610. And this is equal to 1 because it's an ellipse. And the eccentricity, which means c over a, gives us 0.05, which means almost a circle because it's 0, but it's not 0.
So we can use this type of formulas to not only get satellite orbitals, but also the planet orbital.